Okay, this is the Gustech computer that I'm working on. This board right here is the computer. This is a simulator. We have the 4 injectors, it's ignition coils, these 2 yellow, the 4 red LEDs represent the ignition coils, the 2 yellow is the fuel injectors, the red is the fuel pump, and then we have the power. Right, and then over here I have my USB to serial interface. Here goes to my laptop. I'm using Tuna Studio for the software, the interface to the computer. Right now, the Gustech is not supported under Tuna Studio, but when I finally have my first prototype complete, Tuna Studio will support the Gustech computer. Right now, I only have fuel working. Fuel scheduler is finished. Just need to work on the ignition. Some software. See some of the code right here. I'll look glance at some of the code I wrote. All right, I'm working on this is the control. This is like some of the code that's going to control the ignition, but it's not done yet. I'm still working on that. That's the hardest part. So I have to think about it before I actually start coding. You know, design more. It's more of a design challenge than anything else. Right? So I'm gonna go ahead and turn this knob right here. They're gonna change the RPM. As you can see, RPM is what, 512 RPMs per minute, and the engine is running. Once it bars 300 RPM, engine is running, right? And then we got air temperature and PSI, pulse width, and as you can see here, the pulse width matches what's on the oscilloscope, roughly, right? So I have 5.8 microseconds of fuel there. I got coolant and all that, so but yeah, the pulse width is 5.8. If you look at the scope, that's my pulse rate right there. I got about 5.9. That's close enough because of the accuracy. It's gonna be off a little bit, but once we have more sections in the scope, it'll be more accurate. But anyways, let me start cranking up the RPM. See, you can see the RPM going up. And at the same time, at the scope, you see I'm raising the RPM up and down. See right here, we have 6.0 milliseconds. Over here, we have, what is it called? Wait, yeah, 6.0. Right? So, what's here is actually what's on the scope, so it's correct. RPM is correct. We got air temperature sensor right here. We got, what's the coolant? Coolant temperature sensor right here. Alright. And then I'm gonna show you I got an air compressor. Over there I got my hose. The map sensor. I have 2 map sensors on this computer. I got one right here. This one is for the map, for the engine. But this one over here is just a barrel, measuring the atmospheric pressure for real-time barometric correction. Right? That's what I have right here. This one. So this one here is like 2.5 bar map sensor, and I forgot what this one is, but this one is 700 kPa. Right? So I could read up to about 86 pounds of boost with this map sensor here. I can hook. Right now I have the compressor set to like 30 pounds over there. So let me hook this up. I'll put on the cell phone. Hold on. And then I have my PSI gauge. See? Yeah, well, about 20 pounds of boost right there. So let me walk over the compressor and turn it up a bit. See, I can crank this up. crank it up to about what? 70 psi. And then we're gonna see what we can read on the compressor. The hose might blow off, so bear with me. See, we got what? The air compressor is not on, but you see the max reading I got about 75 psi. Alright? But I can crank it up some more. Like I said, this map sensor is good for 700 kPa, so I can get about 86 pounds of boost with this map sensor. And everything working here. So like I said, right now, still in the coding phase. I'm finished with the fuel part of it. The fuel, everything worked great as far as fuel. It had two, like I said, 2 injector outputs, which these yellow leads represent. And then, you know, I have, you know, these 4 coils is going to represent ignition output, but right now I haven't coded the ignition part yet. Once it's done, then I'm going to release the first version of my computer. First version is going to control the first version is going to control it's going to be for 4, 6, 8, 4, 6 and 8 cylinder engines. And also I want to also support 12A and 13B rotary engines with this computer. And then in the next version of this computer, I'm gonna add a wideband sensor to it, and then just, you know, after that I'll just make any whatever updates that need to be made, I'll make to it. Also the trigger wheels on this first version of the computer, I'm gonna support distributor 36-1 trigger wheel and 16-2 trigger wheels on this computer. And also I might support because I have my car over there, I have the 2RZ engine. I'm gonna support the 2RZ trigger wheel setup. I think it's a 22 -2 or -1 trigger wheel on the engine on the front. You know, they have a, I can't really see it, but you know, that behind it's too dark so you can't see it, but they have a I think a 22-1 or 22-2 trigger wheel on the crank. So I'm gonna put that in there. I'm gonna make it very simple to set up and config, you know, very straightforward, not complicated. Try to make it simpler than the Mega Squirt. You know, it's not gonna support all the features and bells and whistles that Mega Squirt does, but you know, it's very simple. I mean, let me just give you a run through of what the software, what I can do in the software. In the software, you go to basic setup. You could check the engine constants. You could set required fuel, injector open time, battery correction. You know, map sensor. Like I said, it's only one map sensor, 700 kPa. Soft rev limit, hard rev limit. Rev limit type, you could do fuel only, fuel and spark, or spark only. This is TPS settings, rev limit stuff. What else? Trigger setup, like I said, you're going to be able to do distributor 36-1, 60-2, and like I said, I'm going to put the 3RZ setup in here. So what I'm going to do, as I learn more trigger wheel for different engines, I'm going to make it very simple. For example, instead of putting like some kind of convoluted number or some kind of thing in there, like I'm just gonna say like 4G63. That way you know you have a 4G63 engine and you use a stock 4G63 crank trigger. You just set that up and everything will be easy for you. That's what I'm gonna do. Also we have, you know, ignition coil settings. I mean, that's not done yet, but oh, this is dual. You're gonna be able to control the dual, crank and dual, run and dual for the ignition coils. And then I'm not gonna use those smart coils because this computer is gonna control the coils directly, you know. So no smart coil, just regular old, plain old dummy coils, whatever you wanna call it. And then here we have crank prime fuel, you know, prime fuel, and then we have cranking fuel, and then this is the warm-up fuel. So once the engine reaches up to 160 degrees Fahrenheit, then no more fuel enrichment. That's what basically means. This is in percentage. How much percentage you want the engine, how much fuel you want the engine to get when it's cold, right? Just play with those numbers. And by the way, this is the primitive setup that I'm using. I just need to edit my configuration file so that way I have the nice fancy, you know, the graphical 3D type display stuff. I haven't gotten around to setting that up, but I'll do that when I get time. For example, there's like, you know, the fancy stuff like this, you know, with the graphs and all that stuff. For the, you know, that's what I'm gonna change it, but not right now. And here you have the fuel table. The fuel table on this computer is 15 by 15, so this is way more than enough to do what you want to do. And this table, it interpolates between the various tables. See right there? So basically the computer looks at, if you notice that there's 4 tables, 4 numbers here, and those numbers are, you know, going through an algorithm to you know, figure out, you know, the number, the best number. Well, now it's the best number, but how much fuel we need to add, and it's not going to actually be 68 or 69, but it's going to be some number between in that range. And that's how I know how much fuel to calculate, put in the engine. So it's going to be, like I said, interpolated. This is the fuel table, 15 by 15, max KPA 700, minimum I think is 24, I think, on this, and RPM, I think the max RPM, I think I have an internal limit of 15,000 RPM. I don't think anybody need to go over 15,000 RPM, so, but 15,000 is the limit on this computer. That's what I hard coded. Spark table, same thing. You have, you know, 15 by 15, and as you can see, here's a 15 by 15 spark table. Same thing happens again. The spark is interpolated, as you can see right here. It's probably like maybe 14 or something, I don't know, I'm just guessing, but it's interpolated between those 4 cells that you can see. And as you can see, as I change the RPM or I put boost, you know, see it moves, you know, so I know it works, right? What else? That's the tune in. And then features, I'm gonna have some features. These features are easy. I haven't gotten around to finishing the features, but for features, I have nitrous control, where you could turn on the nitrous at a certain RPM, or when the coolant is above a certain temperature, or when the TPS is above a certain temperature, you could turn it off at a max RPM, and you could tell it how much degrees to retard, and all that good stuff, right? See, right now it's turned off, so there's no settings there, but as soon as you turn it on, then you can adjust these settings, right? You can adjust these settings to whatever you want to set it to, right? Same thing with the launch control. We'll have launch control, so you could have a switch like on a steering wheel, so you could have the engine lock at a certain RPM and retard the timing, and you know, basically, you know, you turn on the switch, you step on the TPS, you step on the gas, and the engine stays at a certain RPM, certain ignition timing, and then when you release that button, boom, you know, the car could launch. It's gonna hook up to a relay. You could, you know, relay could do whatever, you know, control, you know, trans brake, whatever, right? But that's the purpose of the features. I haven't coded the features yet because it's very simple to code. You know, I'm coding the hard part first, all right? And the other feature we have is the fan. The fan stuff that I know that works. That's the fan temperature on and off. 200 degrees off, 180 degrees. All right. Let me close that. So there's an LED on here. Is there LED for the coolant, for the fan? No, I don't have the I don't have the LED for the fan yet. But anyways, it can control the fan. What else? And that's it. So that's my Gustech computer in a nutshell. Hopefully, I try to get this done before I was trying to get this done before the end of the year, but I don't think it's gonna happen. You know, I have more important things to worry about. You know, family and the wife and all that stuff. So hopefully, by maybe if I keep going at the rate I'm going, maybe March, I don't know, February, I should have the software done. And once I have the software done, I just gotta use Eagle software and start doing the schematic for it, you know. And then, you know, and then once I get the schematic done, then I'm gonna have to get someone to you know, make the board and stuff for me, and then we'll go from there. Then I'll make some prototypes, and then we'll start testing. Okay, bye.